Hello Year 12 single mathematicians, just going to continue with some revision topics. This one is a mechanics revision topic which combines SUVAT and variable acceleration, so just a couple of chapters that are closely connected in the textbook. So things you need to know, mainly how to identify what's a SUVAT question and what's a variable acceleration question. So SUVAT is just the slang term for constant acceleration. So when the acceleration is just a number. So if you see the word constant acceleration, you know that's going to be a SUVAT. We also use the word uniform acceleration, that would be a SUVAT question. And maybe if something's moving freely under gravity. Vertical motion, that would be a SUVAT question. Versus variable acceleration. And for variable acceleration, that would be everything else. So if they don't explicitly tell you it's constant acceleration or uniform acceleration or something moving freely under gravity, then it has to be variable acceleration, where you go between displacement, velocity and acceleration by differentiating with respect to t, and to go in the reverse direction you integrate with respect to t. Good news is, in the internal exams you'll be given the formulae for constant acceleration, so the SUVAT formulas, which are v is equal to u plus at, s is equal to half u plus vt, v squared equals u squared plus 2as, s equals ut plus a half at squared, and s equals vt minus a half at squared. One other thing you need to know for the SUVAT stuff is when you've got a vertical motion, so something where the particle is moving freely under gravity, it's an extra assumption. A is equal to 9.8 meters per second squared, and that's always directed towards the Earth. And that's pretty much it, I would say. Obviously the velocities and accelerations are vectors and displacement is a vector, so that should make things in theory easier, but you just got to remember they are vectors. And maybe the other thing that works for both of these is the properties of a velocity time graph. So for a VT graph, just say we'll do a straight part and a curved part. Gradient is equal to acceleration. And area is equal to distance travelled, or displacement if it goes below the x-axis. So gradient, straight lines means constant acceleration, curved lines means variable acceleration, but the properties of gradient and area hold whether it's constant or variable. Okay, let's have a look at what a question might look like. So e.g. number 1, you've got a car is moving along a straight road with uniform acceleration. Keyword uniform. Effectively means SUVAT. The car passes a checkpoint A with speed 12, another checkpoint C with speed 32. The distance between A and C is 1,100 meters. Find the time taken by the car to move from A to C. So a SUVAT write down everything you're given. So displacement is definitely 1100. Initial velocity is 12. Final velocity is 32. You don't know what the acceleration is, and at this point you don't care. But you do know what the time is. The time is the thing you want to work out. So you need to state the formula linking S, U, V, and T, which is S equals half U plus V T. Substitute in the bits you know. So 1100 equals a half, 12 plus 32t. And when you make t the subject, what's a half times 12 plus 32? So 1100 divided by that answer, which is 50 seconds. It takes for the car to move from A to C, which makes sense. Then part B, given that B is the midpoint of AC, find the speed with which the car passes B. So, how are we going to do this? B is the midpoint of AC, find the speed with which the car passes B. So let's try SUVAT again, but be careful. So obviously it's the midpoint is halfway there, so we're going to know that is 550. The initial velocity, let's just assume we're going from A to B. So start to midpoint, that would be 12. Its velocity halfway is the thing we want to work out. A, I haven't worked it out, don't know what it is. And T, we know the time taken to do the entire journey, but to get halfway, it is not half the time, so you don't know that either. Because at the start it's gonna travel. It's going to take longer to travel longer distances, but at the end, when it's at a highest velocity, it's going to be traveling the same distances in a lot less time. So yeah, we don't know A and T. So in other words, we have to find something which is common to A and B that we can work out, and it's the thing we haven't been asked to work out, which is the acceleration. So I'm going to go back up to part A and work out the acceleration. Using v squared equals u squared plus 2as. If you made a the subject, you'd get v squared subtract u squared over 2s, which is equal to 32 squared subtract 12 squared over 2 1100s. To give you 0.4. Then you can write that in there, and now there's 4 bits of information, or 3 bits of information plus the one we want to work out. So a formula linking S, U, V, and A. V equals u squared plus 2as. So V is equal to the square root of 12 squared plus 2 0.4 550s. Type that into your calculator. And round it to 3 significant figures, 24.2 meters per second to 3 SF. Okay. What other questions could I ask you? So in EG number 2, a pebble is projected vertically upwards with speed 21 meters per second from a point 32 meters above the ground. find the speed with which the pebble strikes the ground. So firstly, we've got an object moving vertically and freely under gravity. In other words, there's nothing attached to it or anything, or nothing resisting it. Just the only force acting on it is its weight. So this is where we use SUVAT again. So SUVAT, but with A is equal to 9.8 meters per second squared, directed towards the ground. So this one's a little bit more complicated, so I'm going to draw a sketch. So part A, we have a pebble. It's being projected upwards with a speed 21 meters per second, and it's a point which is 32 meters above the ground, so the ground is there, and that distance there is 32 meters. And this pebble will go straight up, reach a maximum height, and then come back down and hit the ground. And we want to find the speed in which it hits the ground. So just as it's on the point to hit the ground, that speed itself, not the speed just after when it's come to a stop, but the speed it strikes the ground. So first thing we're going to do is determine what value the acceleration is going to be. It's going to be a plus 9.8 or negative 9.8. Now I'm going to assume that upwards is a positive displacement in a positive direction. So when this particle is moving upwards, that's a positive direction. When it changes direction and starts moving downwards, that's the negative direction. So up is positive, and because acceleration points down, A would be minus 9.8 meters per second squared for this motion. So SUVAT S would be, again, because this 32 meters below where we started, negative 32. U is equal to 21. V is unknown. One thing we do know about it is going to be a negative answer because it's moving downwards. A is negative 9.8. T is unknown and we don't care about it at the moment. So what formula links S, U, V and A? V squared is equal to U squared plus 2AS. V is equal to negative, in this case, the square root of 21 squared plus 2 negative 9.8 negative 32s. If you type that into your calculator, see what you get. Negative 32.7 meters per second to 3 significant figures. I've almost been a little bit too clever because the question said the speed, and speed doesn't have the negative sign, so I'd have to state 32.7 meters per second. Right, that's part A done. Part B, we want to find the total time for which the pebble is more than 40 meters above the ground. So obviously it's already 32, but at some point it's going to be a little bit higher, so we want that distance to be 40. And we want the time effectively, if we knew the time where it first passed the 40 meter threshold and then the time where it returned to the 40 meter threshold, the total time for which it is above that would be the difference in those two times. So it's another SUVAT question. However, displacement S is relative to the starting point, and relative to the starting point, the displacement is a positive 8. So 8. Initial is still 21. Final is unknown. acceleration is still initially going against gravity, so negative 9.8, and the time is the thing we want to work out. So S equals ut plus a half at squared to give you 8 equals 21t plus a half negative 9.8 t squareds. If you take everything to the left hand side and make it look like a quadratic, you get 4.9 t squared. Subtract 21t plus 8 is equal to 0. Going to be lazy and use the equation button on the calculator. Typing in the coefficients of 4.9, negative 21, and 8 to give you two possible answers. Either t is equal to 3.86 or 0.423. The three significant figures, and if you took the difference between those two times, that would give you the time for which it was above 40 meters. So 3.86 subtract 0.423 gives you it's always good to show the workings as well. 3.86 subtract 0.423 to give you 3.44 seconds to three significant figures. I probably should have used the exact values, to be honest, just in case I got the last digit out, but that's up to you. Now I need to sketch a velocity time graph for this motion of this pebble. So velocity time graph. Already made an error. Velocity time graph is going to go negative for velocity time graph, TV. So the first thing that should be obvious to you is because this is a vertical motion question, which means constant acceleration, you can ask yourself, is this going to be a curved line or straight line? And because you know the gradient is equal to acceleration, you know that it should be a straight line. So before I sketch anything, I know I'm only going to be drawing a straight line. And what I would do is label in the intercepts, and it starts off with a velocity of 21. And as it moves upwards, the velocity starts to decrease until it reaches 0. And then when it gets to through 0, it changes direction and it goes negative until it hits the ground. So that would be an example of a VT graph for this pebble, where the gradient would be minus 9.8, and we didn't work out the time it took to get to its max height, so I can't label that in, but that would be, maybe I put in the final velocity, which was negative 32.7. I'll put that in just in case. And that pretty much would be it. There's one more style of question that looks of it I've put in. Probably going to be a variable acceleration question. It is. So with a variable acceleration question, you normally get a formula like this. And that kind of gives it away. Doesn't mention the word constant or uniform anywhere. So we know we're going to have to use either differentiation or integration or a mixture of both. So part A requires us to find the values of t when the body is instantaneously at rest. So in other words, v is equal to 0. In some mark schemes, you just get a mark for writing v is equal to 0. And then you solve this quadratic. gonna see if it's one of the easier ones. Yes. So that would be -2 -5 to give you two answers. T is equal to 5/3 or 2. Both of these measured in seconds. Part B. Find the acceleration when t is equal to 4. So the acceleration, well, we haven't got a formula for acceleration, but we can get one by differentiating once. And that gives us the acceleration at any point, and as you can see, that is not just a single number, it is a function of t, hence the variable acceleration part. So when t is equal to 4, the acceleration is 6 times 4 subtract 11, which is 13 meters per second squared. And then the third and final part is the hardest part. Find the total distance travelled in the interval 0 to 4 seconds. Now, because there's not much context in this question, it's not obvious whether this particle has moved or changed direction. Because when I integrate, I get a formula for displacement, and displacement is always just relative to the starting point, so that might not actually coincide or correspond perfectly with distance travelled, because if a particle changes direction, then it might have moved a lot more distance than what the displacement would indicate. So for these questions without the context, where I have no idea if the particle has changed direction, I need to draw a sketch, and preferably a VT graph. Now this velocity time graph, I'm going to do this pretty quickly, but the y-intercept is 10, given in the question, when you put t is equal to 0 in. We actually worked out when v was equal to 0 in part A. It was 5/3 and 2, and then you'd have parabola, a happy parabola like that. So we want to go up to t is equal to 4, and the distance travelled would be that distance plus that distance plus that distance, and you're going to need to use some definite integration to do this. So total distance, you split it up into separate things. It'd be integrating between 0 and 5/3, 3t squared subtract 11t plus 10 with respect to t, which is add 1 to the power, divide by the new power, so t cubed, 11 over 2t squared, 10t between 0 and 5/3. I'm going to be lazy and not actually write in the substitution and just write in the workings on my calculator, but I would not encourage you to do that in an exam. Always show every single step, particularly the step I'm avoiding right now. Okay, that should give you 325 over 54. Then you integrate between 5 over 3 and 2. So 3t squared subtract 11t plus 10. Again, I'm going to skip major parts of the workings for this. Just type it directly into my calculator. And this will be a negative because it's below, so that's negative 0.0185 ... And then finally between 2 and 4, that would be 10. And then the total distance would be these three added up, but you'd have to make sure you choose the positive number for that and round that to 3SF. So total would be the fraction plus this made positive plus the 10 to give you 16.0 to 3SF, and that is measured in meters, and that would be it. So in order for you to practice some of these questions, it's going to be the review exercise. And it's going to be page 197, question 1, up to question 5, but also a few more parts which would start at question 16 and go up to question 19, and that would be it.